This is the hints for National 5 Numeracy Sheet 1. In question 1 we're asked to evaluate the fractions 2.5 plus 1 over 3/7 and 1 2/5 times 2 2/3. Now the first thing we need to do for both fractions is we need to turn them top heavy. We do that by timesing the big number by the denominator and adding it to the numerator. So the first fraction turned top heavy would be 5 over 4 plus 7 times 1 plus 3 is 10 over 7. So we do that for both fractions. I'll let you do part B yourself. When we're adding and subtracting fractions, we need a common denominator. Now you always look for the lowest common denominator, and for 4 and 7 the lowest common denominator is 28. Okay, so we get that by timesing the first fraction top and bottom by 7 and the second fraction top and bottom by 4. Okay, so I'll let you finish that off for yourself. Then you add the numerators, convert it back to a mixed number. When you're multiplying, what we do is we times the top and we times the bottom. So once you've turned it top heavy, you multiply the numerators, multiply the denominators, and then turn it back into a mixed number. In question 2 we have a similar problem where we're looking to do 2 3/4 plus 2 1/10 divided by 7 over 16. Now the first thing I would do here again is turn this fraction top heavy. Okay, so I would turn them all top heavy by timesing the big number by the denominator, adding it to the top, and that would be step 1. Now in step 2 you'll notice that we have a plus sign and a divide sign, and using your rules of BODMAS we need to do the division first. So when you turn it top heavy, you want to take away to the side 2 1/10 divided by 7 over 16, and because we're dividing by a fraction we need to flip it in times. Okay, so you'll turn this into a top heavy fraction. I'll leave you to finish that off, but we do it with division, we flip it in times. Okay, we can't divide by a fraction, so we flip the 7 over 16 in times by 16 over 7. Once you get an answer for that, you then add it to your 2 3/4, which you'll have turned top heavy. So in question 3 we're told that an antique teddy bear, it was £350 in 2009 and has increased in value at a rate of 12% per annum, and we're looking to find the value of the teddy bear in 2014. So if it's a 12% increase, that means that the teddy bear is going to be 112% of the original value at the end of every year. And if it's a consistent increase, we can write that in a shorter term. So we need to turn 112% into a decimal by dividing by 100. Okay, we put that inside a bracket, so that answer will go in there. Your power is how many years that is from 2009 to 2014, so that's what goes in there, and then you times it by the original value of the teddy, which is £350. So you turn your percentage into a decimal, it's to the power of how many years between 2009 and 2014, and you times it by 350, rounding your answer to 2 decimal places because we're dealing with money. In question 4 we're told that AC Milan is currently worth $856 million and that the club has depreciated by 9% in the last year. So we're looking to find the value of the club and round our answer to 3 significant figures. So if it's depreciated by 9%, that means that it's 91% of the original value. So 856 million is 91% of the original value. So to tackle this question, we want to find 1%. So what do we need to divide 91 by? to get 1. Do the same to both sides, and then we find 100% by timesing by 100. Okay, so we time both sides by 100. So 3 steps, and that will give you your original value of the club. And remember, round your answer to 3 significant figures. Okay, you've done all the hard work, don't lose that last mark. In question 5, we're told that the price for Paul's summer holiday is £894.40, and that includes a 4% booking fee. So what is the price of the holiday without the booking fee? So the booking fee is the price you pay on top of your holiday. So if it's a 4% booking fee, that means the total price of your holiday would be 104% of the value without the booking fee. Okay, so 104% is equal to £894.40. Kind of similar to the last question. Find 1%, then find 100%, and that will give you the original value of the holiday. Now, because the 4% is added on to your holiday price, your answer will be lower than the £894.40 that you started with. In question 6, we're looking to calculate the volume of this tank. It's constructed with a cylinder and a hemisphere on the top. Now it's telling me that the diameter is 80 centimetres and the total height is 1 metre. Now we'll deal with the hemisphere first. The volume of a sphere is equal to 4 over 3 pi r cubed. Now we're told that the the diameter is 80 centimetres. So to get the radius, we need to half that. So your radius is 40 centimetres. So we'll substitute that into your calculation. Now doing this calculation here, it's going to find you the volume of a full sphere. Now because we're looking for a hemisphere, you work your way down to an answer, and then you need to divide it by 2, because a hemisphere is half of a sphere. We can then calculate the volume of the cylinder using the formula V equals pi r squared h. So again we use the same radius because it's the same as the hemisphere, but now we need to work out the height. Now if we know that the hemisphere has a radius of 40, that means it's going to be 40 centimetres tall at the top, which means the height of your cylinder is 60 centimetres. Okay, so you calculate each volume, and then to find the total volume you add the volume of the cylinder and the volume of the sphere. In question 7, we're told that the truncated cone is formed by cutting a small cone off the top of a larger cone, and we're looking to calculate the volume. So we've got everything we need in this diagram. We've got our heights and our radii, and the volume of a cone is 1/3 pi r squared h. Okay. Now in both cases, for both cones, you are given the diameter and the height for each cone. So to find the radius, you half the diameter. I'll let you figure that out yourself. So you've got 2 separate calculations. You do the large cone, and then we're going to take away this small cone at the top. Okay, it's been cut off, so we need to find the volume of that and take it away. So the volume will be the volume of the large cone, take away the volume of the small cone. Okay, we're using the same formula for both cones, but be careful because you're given the diameter for each cone. And I hope that's helped.